All right. So same learning target. I can determine patterns in a sequence that determine linear and exponential functions. We're going to identify the next two terms kind of like yesterday. So on sequence number 1, what is happening each time? By how much? Close. So anybody else, what do y'all think? How much? What's the change from the first term to the second term to the third term? Is it adding or multiplying? Okay, so if it was adding, you would be adding 1.2, but then that next one would have to be 3.6. So it's not adding, it is multiplying by how much? 2. It's doubling, okay? So 1.2 times 2 gives you 2.4. 2.4 times 2 gives you 4.8. So what's my next term? Times 2. 4.8 times 2 is what? Thank you. 9.6. And the next term, again, we're just doubling, right? 19 point, close. 19.2, all right? So, is that linear or exponential? Exponential, okay? When you're multiplying each time, exponential. Okay? So, it's either one of these two. We already talked about that. And yesterday we talked about two other terms, arithmetic and geometric. So, is exponential arithmetic or geometric? Do you remember? So, geometric is exponential. And linear is when you're adding each time. That one's arithmetic, okay? You're going to see that on today's notes when we get there. So, sequence number 2, what's happening each time? Adding 5. So, adding each time. What would you add? Okay. So I heard sequence 1 is adding the number before it again, right? Oh, sorry, but I mean, like, to get this one, you add this one. Yes. So here's the deal. It's linear if you add the same number each time. So you see how what you're talking about is adding a different number each time, right? And if you're adding the one before it twice, that means times 2. Times 2, times 2. That's good. I mean, you're thinking outside the box, so that's cool. But no, it has to add the same number each time, and that's what this is doing. Same 5, same 5. So 25 plus 5 is 30, and then my last term is 35. So what is the type of function? Linear. Great. So you get the idea. Also linear, we call it arithmetic. All right. Now, yesterday we started this, and most of us got pretty far. I was going to end up cutting it off at the first page, okay, so we don't get lost in the assignment. So yesterday we were doing, come on, there we go. Pascal's triangle worksheet, right? So if you have this done, A through F, done, you can pass that up. Now, I know I didn't tell you it was due today, so if you're not done with that, you can finish that, turn it in tomorrow. But this sheet, A through F, if it's done, pass it up, make sure your name's on it. And just a reminder on how to do this, and if you weren't here, this is how you do it, okay? To get a blank, you just add the 2 above it. So 4 plus 1 gives me 5. So to get this one, 10 plus 5, 15. 5 and 1 gives you, and then down here, for example, this is blank right here. There's not 2 above it, right? So I take the one below it minus the one next to it. So 35 minus 15 gave me 20. And it makes sense because 20 plus 15 gives you 35. So, okay. So if you got it, you can pass it to the front. If you're not done, you can turn that in tomorrow. Cool. And again, just front side, so don't worry about the back anymore. Just the front side. So if you got the front side done, do you have the front side done? Okay, because that's you're looking at the back side. Okay. Cool. All right, so I'm going to pass out today's notes. This class has a book, but we are not going to make you have to carry that around, so I'll be printing out the stuff for you. Okay. So here we go. All right, so you should be looking at this 1.1 arithmetic and geometric sequences. Where did I put it? Cool. All right, so we're going to be focusing, and notice the book uses the other words I was telling you, arithmetic and geometric, okay? So remember, adding and then multiplying. Okay, you're going to be able to do those objectives. Now this first one is kind of weird. It's really actually simple. If we have baskets of tomatoes, okay, let's read it. Brenda is at the farmer's market. There are several baskets of tomatoes on a table. Each basket contains 6 tomatoes. I cannot make a straight line. Cool. What sequence would Brenda create if she listed the number of tomatoes in a set of baskets? So, one basket is how many tomatoes? 6. 2 baskets is how many? You get the idea. 3 is 18. So my sequence, okay, so listing the numbers would be 6, 12, 18, and then the next one would be what? 24, right? Keep adding 6 each time. So what kind of sequence is that when we're adding 6 each time? What kind of sequence is that? Arithmetic, right? When you're adding each time, arithmetic. Or it's a linear function. Arithmetic sequence gives you linear function by adding each time, okay? Cool. Okay, down here, sequence 1. Now, we got these 2 examples, all right? And the first one, we have, what are these things called? Put them in your, dig stuff out of your mouth, right? Toothpicks. So, those toothpicks are making the first one is making a square, right? So how many toothpicks we got? 4. Now how many squares on the next one? 2. Now, you might think that's going to give you 8 toothpicks, but I want you to count them. There's 7, right? So you see, like right here, this toothpick is shared by both, so you're not doubling up on that, right? Okay, so what they want you to do is given these terms, they want you to, and now, I know it says use toothpicks, but guess what happens when I bring sharp, pointy things to school? People misuse them, poke people, blood everywhere. All right, so again, we're going to draw these instead of using toothpicks. You're going to use toothpicks to build the next two terms, so I want you to draw the next two terms. So you might have to draw kind of small, maybe off to the side. So what would the next two figures look like? Okay. And then also do the same thing for sequence 2. You can see the coins. These are actually called, what are they called? Counters, okay? So you're going to do the same thing for these counters over here. So I want you to draw the next two terms, okay? So I'm going to give you a minute or two. So I'll finish it down here. So you had your first one. Basically that. So you'll have 4 squares, and then five squares. Now what's going on with these counter coin things? What's happening each time? Doubling, right? So can you make 1, 2, 4, 8, 16? Coins? I know that looks kind of bad, but YOLO. Timer. Why you do this? Oh. No. Okay. Anyways, and then you could draw the next one. $32 coins. It's a lot of coins, or counting things, whatever. All right, so if you didn't draw the 32 one, that's fine. You could just put coin times 32 or something. All right. So if you're done with that, flip it over, and you're going to fill out a table based on that stuff. Okay, the same exact scenarios. So the number of toothpicks, fill out the table. Number of counters, fill out the table. And I want you to for sure tell me the patterns. So I know you can for sure answer this. 1 and 5, okay? What are the patterns after you fill in that table? Go ahead and do that now. So again, we started with 4, then we added 3 each time, right? All right, and then over here, started with 1 counter. We doubled it each time. Cool. All right, so at number 1, what'd you get? What was our pattern? Adding 3 each time? Okay, so now I want you to think about this. Using the number 3, how do I get from these numbers to these numbers? Okay, so how can I get from 1 to 4? Plus 3, okay? But on number 2, if I add 3, that would not be 7, right? So that's why they gave us a little hint here. Let me back this up. So the hint, record the multiples of 3, okay? So let's think about the multiples of 3 off to the side here. 1 times 3 is, quickly, 1 times 3 is, all right, 2 times 3. Okay, and then 9, 12, 15, 18, and then 21. Now, look at this over here, these multiples of 3, and look at the number of toothpicks. What do you notice? They're 1 away, right? So basically, if I took this number times 3, I would need to take that number and then do what to get over here? Plus 1. So we can make a rule. Times 3 plus 1. So pick any number. 5 times 3, 15. Plus 1, 16. Okay? So that's going to be our rule. 3x plus 1. Or 3n plus 1. Sometimes you use n instead of x. Either way, it's a variable, right? 3 times the term number, adding 1. So you see how that works, right? So if you know the multiples, if you know it's adding by 3 each time, just figure out if you need to add or subtract from that, okay? Question number 3. How does the pattern that you mentioned in question 2 appear in the figures that you constructed, okay? Well, add 3 toothpicks, right? That's how it was in the figures. Every time, added 3 more toothpicks. Okay. And then how many toothpicks would you need to build the 10th term? If I have a rule, and it says find the 10th term, what do? I have a rule, and you know x is the term, and it tells me the term is 10. So y'all know about substitution, replacing x with a number. That's all you got to do. Okay? So 3x plus 1 is now going to be 3 times 10 plus 1. Okay? What would I get? What would I get? 3 times 10 plus 1. 31. Not too bad. Okay, so I could ask you for the 100th term, and you could just plug it in and get the answer, right? All right, what's the pattern for sequence 2? With the counters, what do we do each time? Yeah, you do. Didn't you fill out the right table? What's happening each time to those numbers? All right, multiply by 2. So what relationship do you observe between the term number and the number of counters? Now look at this hint. Okay, powers of 2. All right. So they're talking about 2 to the 1 power, 2 to the 2 power, 2 to the 3 power, 2 to the 4 power, blah, blah, blah. Okay, so 2 to the 1, 2 to 1 power is what? Just 2, okay? 2 squared is 2 times 2, 4. 2 to the 3rd power, what do you think, McManus? 2 times 2 times 2. McManus, what do you think? 2 to the 3rd power, 2 times 2 times 2. Sure you do. 2 times 2 times 2. 4 times 2. So you gave me the next one, 16. Okay. Well, so when it's third power, it's just 2 times 2, and then that number 4 times 2. So, all right. So you get the idea. Now, do these match up with the counters? Exactly, no. But what do you notice? They're kind of offset, right? So here's the deal. 2 to the power of the term, the term number needs to be this. All this needs to go back 1, okay? So here's the idea. When it's exponential, when you're multiplying each time, okay, your rule, instead of having a big X, we're multiplying by 2, so we're going to have a base of 2. And instead of a big X right here, since it's exponential, we're going to have a little x in the exponent, okay? So when you're multiplying, x is in the exponent. But we just said that the term numbers are off, okay? So this is really 2 to the 0 power, right? This is 2 to the 0, 2 to the 1, 2 to the 2. So how do I get from here to here? From 1 to 0, from 2 to 1. What's the difference between this and this? The difference between this number and this number is 1 away, okay? So the idea is our exponent is going to subtract 1, okay? So again, if your power 2 to the term number is not exactly the same, you can add or take away from it. That'd be fine, okay? So here's our rule. How does the pattern that you mentioned in question 6 appear in the figures that you constructed? Okay. Again, in the pictures, we were doubling the counters. Okay. Now they're going to ask us for the 10th term. 10th term. So, like I did up here, I take the 10 and I replace x with the term number, right? In the back. So, I'm going to plug in 10 right here. Okay, so 2 to the what power? 10 minus 1. Okay, so let's write that down. 2 to the 10 minus 1. What's 10 minus 1? Okay, 2 to the 9th power. This is not a trick question, but I have a feeling I know what you're going to say. What's 2 to the 9th power? What's 2 to the 9th power? Anybody? What do y'all think? Okay, so I'm glad you said something. So 2 to the 9th power is not 18. That would be 2 times 9, right? So this is 2 to the 9th power. That means you're going to do 2 times 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 2. 9 2s. Okay? That's a lot. Now I know you don't have calculators in your hand right now. Okay? But you could, if you had them, type it in. Any guesses before I hit enter? All right. 512. So if you multiply 2 9 times, you get 512. So that shows you something about doubling. If you start doubling something, it starts growing pretty quickly, okay? It's better to multiply over time than just to add the same amount, okay? So I'm going to leave number 9 for you to answer in a complete sentence or two. Tell me how are those sequences kind of the same? How are they different, okay? So that's for you to do now. I'll come around and see how you're doing.